Imagine the night of December 22nd, 2027. The world continues its usual course. Illuminated cities, people gathered in their homes, celebrating the approach of the holidays. But amid the daily routine, news arises that shakes all of humanity. Telescopes and early warning systems around the planet have detected that a meteor, similar to the asteroid 2024 YR4, discovered a few years ago in Chile, is on a direct path toward Earth. The asteroid 2024 YR4, monitored by the international scientific community since December 27, 2024, has an estimated diameter between 40 and 90 meters. An object of this size, although small compared to the asteroids that wiped out the dinosaurs, represents a considerable threat to any populated region on the planet. According to the most precise calculations, an impact could devastate an area up to 50 kilometers around, potentially affecting millions of people. Although the probability of an asteroid like this directly impacting Earth is extremely low, in the case of 2024 YR4, it was estimated at 1 in 26,000. The scientific community and space agencies leave nothing to chance. In recent years, humanity has intensified its efforts in planetary defense. Agencies such as NASA and the European Space Agency have taken historic steps to prevent a disaster. In October 2024, the European Space Agency's Hera mission was launched to study the effects of NASA's DART mission on the Didymos and Dimorphos asteroid system. The DART spacecraft successfully impacted Dimorphos in 2022, managing to alter its orbit by 32 minutes, marking the first real demonstration that humanity could change the course of a potentially hazardous object. This historic feat, followed by the Hera mission, represents the hope that Earth is not defenseless against cosmic threats. In August 2024, NASA conducted an unprecedented simulation exercise. A fictional asteroid with a 72% probability of impacting Earth tested the international response capability, decision-making in emergency situations, and the effectiveness of planetary defense protocols. The data collected from these simulations and real missions continuously feed the preparation for possible future threats. But what would happen if, in 2027, one of these objects passed through the atmosphere and crashed onto the Earth's surface? The first sign would be a global alarm. Alert systems, coordinated by institutions such as the Asteroid Terrestrial Impact Last Alert System, ATLAS, would issue warnings to world governments, who would immediately activate their emergency protocols. Depending on the location and time of impact, authorities would evacuate the population at risk, close air routes, and activate civil protection systems. As the meteor approaches, the Earth's atmosphere begins to slow its speed, causing an intense glow visible for hundreds of kilometers. If the object is large enough, it will not completely disintegrate before reaching the surface. Instead of exploding in the air, as happened with the famous Chelyabinsk event in 2013, it will impact the ground with energy equivalent to tens or even hundreds of nuclear bombs. The impact site would be transformed into a crater several hundred meters in diameter. Within a radius of up to 50 kilometers, the shockwave would knock down buildings, trees, and everything standing. The air pressure and generated heat would destroy infrastructures, causing widespread fires and immediate devastation. If the impact occurs in a densely populated area, the human and material losses would be catastrophic. The resulting seismic wave could be felt hundreds of kilometers from the epicenter, causing tremors, landslides, and possible disruptions in the groundwater system. The dust and debris thrown into the atmosphere could darken the sky for hours or even days, affecting the local climate and hindering rescue and relief efforts. The immediate consequences would be devastating, but the long-term effects would depend on the location of the impact and the exact size of the meteor. If the object fell into the ocean, it could generate tsunamis capable of affecting distant coasts, wiping out entire communities within minutes. The international response would be swift and coordinated. Rescue teams, humanitarian aid, and disaster management experts would be mobilized immediately. Satellites and drones would fly over the area to assess the damage and search for survivors. Hospitals in the region and neighboring countries would prepare to receive thousands of injured people, while governments would allocate extraordinary resources for reconstruction. The economy of the affected region would suffer a severe blow. Destroyed infrastructure, interrupted communications, and the need to relocate millions of people would pose significant logistical and social challenges. Prices of certain products could temporarily increase due to the disruption of supply chains, and global markets would react to the uncertainty. However, even in the midst of tragedy, humanity would demonstrate its resilience. Social media and the press would focus on conveying messages of support and solidarity. International organizations would coordinate aid, and science would seize the opportunity to closely study the effects of such an impact, further refining planetary defense strategies. In the long term, the impact of a meteor in 2027 would serve as a stark reminder of our planet's vulnerability and the importance of international cooperation in science, technology, and risk management. The experience would reinforce investment in early detection systems, the development of new technologies to divert or destroy dangerous objects, and public education on how to respond to such emergencies. Although the probability of this happening in the near future is low, constant monitoring and recent advances in planetary defense, such as the DART and Hera missions, allow us to look at the sky with greater peace of mind. Humanity has never been as prepared as it is now to face the challenges posed by the universe. Thus, the fall of a meteor on Earth in 97, although unlikely, would be a momentous event that would test not only our technology, but also our capacity for response, solidarity, and adaptation. A reminder that, amid the vastness of the cosmos, Earth remains our only home, and its protection is a responsibility shared by all humanity.